Hello everyone. So today we will discuss memory management partitioning. So let us have a look on it. So the first the topics. Let us look at the topics we have to discuss today. Is why memory management, what is memory partitioning, and why memory partitioning, and types of memory partitioning. And in that we will look fixed partitioning and variable partitioning. So let us look what is it here. I have so much memory, but I just cannot manage it all. So with that note, let us start why memory management. So memory management, we all know how much memory is important. So in order to we have to manage memory, and in memory management we keep a track of each memory location status, whether it is free or allocated. It helps in dynamic allocation of memory to all the programs at their individual request. And if the memory is not required at all, then it also frees that memory so that other process can come and execution will be held. Okay. So that is let us look what is memory partitioning. So in order to memory management, partitioning, it is a process that refers to divide the available memory into a smaller section. As we also know that memory is a block, like memory is a large block, and each process is not that much larger. So we have to like we just what we do actually is to partition it in a smaller bytes, so that each process or a specific process when come, then it is allotted to the designated partition, right? So like why memory partitioning, like hope we got to know like what is memory partitioning. So why memory partitioning? So there are many advantages of memory partitioning. For example, like if you have one process, okay, and if it is in one memory allocate, like if it is in one memory partition, then it cannot interfere with each other memory location. They cannot interfere with others memory location. It helps to improve our system stability. And like also by doing memory partitioning, it ensures that each process has enough memory to run smoothly. And it is also required to achieve multi-programming, and we know how much memory multi-programming is important nowadays, right? Okay, so now let us look like types of memory partitioning we have. So we have two memory partitioning, that is fixed partitioning and variable partitioning. So let us look in greater detail what is fixed partitioning and variable partitioning. So let's start with fixed partitioning. So what we generally do in fixed partitioning, that memory is divided into fixed partition. Okay, and the operating system is generally kept at the lowest byte of memory. It is not compulsory. It can be like maybe it is in like lower byte as well as like it can be in, but generally it is in lowest byte. And process, when process is there, it is classified on the when it entry to the system according to their memory requirement. And we require one process queue for each class of process. And like if process is allocated a memory, then it goes to memory and competes for the processor. And like the number of partition, why we generally do in order to attain multi-programming. The degree of multi-programming is very important. Right nowadays multi-programming is important. So every like memory partitioning enable us to do multi-programming. So like each queue has its own memory region, so there is no competition between queues for the memory. So let us look what is memory presentation of fixed partitioning. So here we can see that each partition has equal amount of memory. So here equal amount of memory is allocated. Like for example, here it is three partitions are there, and each partition has equal memory. But here we can see that there are different partitions. Like first partition is small, the second one is of medium size, and the third one is the large size. For example, we have lot of processes, right? And we also know that each process doesn't require same amount of memory. So if process is a smaller size, then we allocate this partition to that smaller process so that our memory is used efficiently. And if a process is a little bit larger, then we allocate in the medium partition. And like if it is like if the process is larger, then we allocate into the larger process. Hope you got it. Now let us look what is the problem with fixed partitioning. The first problem with fixed partitioning is the determination of number of partitions. So we don't know the number of partitions, how much partitions we require. And also the determination of size of partition is also very challenging, as we don't know how much like small processes are there and what is the size of that processes. So we don't know exactly what is the size of processes and the number of partitions we require. So this is a problematic for fixed partitioning. And the other major problem with fixed partitioning is fragmentation, and which is also two types, that is internal fragmentation, external fragmentation. So let us look what is internal fragmentation, external fragmentation, to know the problems with fixed partitioning. Okay. Before going to that slide, let us look at another slide we have. Is, for example, what is here. Here we can see that there is one process called P1 which is of 2 kb. Okay. And like we have the partition such that like the first partition is of 2 kb, the second one is of 6 kb, and the third one is of 12 kb. But for example, we have one process that is P1, and it requires memory of 2 kb, so we allocate the 2 kb memory to P1 process. It's totally fine, no issues at all. Okay. But here we can say that 6 kb is empty, the partition of 6 kb is empty, and it leads to external fragmentation. It leads to external fragmentation. And next we have, like for example, there is one process which requires 9 kb, so we cannot allocate this 6 kb to that 9 kb process. It is not possible at all, so we have to allocate it to 12 kb section, that is a larger partition. So okay, it's fine if we allocate it. Then what is the problem behind that? So for example, we have just taken one example here. Like if a process that is P3 comes, and it requires 8 kb memory, it requires. Although we can see here 6 kb memory, 6 kb is empty and 3 kb is also empty, right? So 9 kb is already there, but although there is ample amount of space available, but we cannot allocate it, as it like we cannot allocate this, as the first one, it is like external fragmentation, and like here also 3 kb is wasted, that leads to internal fragmentation. So hope so you got to know what is fragmentation. So let us read the definition what we have. If a whole partition is currently not being used, it's called external fragmentation. And if a partition is being used by process requiring some memory smaller than partition size, then it is called internal fragmentation. So hope so you got to know what is fixed partitioning. So now let us move ahead to look what is variable partitioning. So we already know the problem behind fixed partitioning, what we have to, like what the problem we are facing due to fixed partitioning. So what we do in variable partitioning is that we just think that okay, we have memory which is of larger section. Okay. And whenever new process comes, whenever new process arrives, then OS searches for the free block of memory, so that it is enough for that process. And then we keep the rest available memory for the future processes. And also operating system tries to merge the free spaces with the its neighbor one. Okay. So let us look how it actually looks like. For example, it is a memory representation of our variable partitioning. So there is one process like it requires 1 MB, so it is allocated to P1, and it is allocated. For example, like here P2 as well, P3, P4, P5, like it is a memory representation. So when P1 asks for memory, 1 KB MB memory, so like it is allocated. Like we don't have any partitioning, we do the partitioning at when it requires that 1 MB memory, then we just allocate it. Okay. So now we are thinking of ki, like what are the ways or how we can do that partitioning. Like in fixed partitioning we know that we have already like made the partition, but in variable memory partitioning we have several algorithm. it depends on us, or it depends on process which algorithm is best. So let us look what are algorithms we generally follow. So here we have four algorithms, that is first fit, next fit, best fit, and worst fit. So let us look in greater detail what is it. So let's start. The first one is first fit. So what first fit generally do, it allocates, like when a process is there, it allocates the first free partition that is large enough to accommodate that process. It just searches if there is empty space. If there is any empty space, then it just allocate the first free partition that is enough to accommodate that process. Okay. So it has some advantages and disadvantages as well. So advantage, it is fastest algorithm, as like it doesn't require whole memory to search it. It just like if the process is there, and if it is like if the memory partition is free, if memory is free, then it just allocate if it is sufficient to keep that process. So that's why it is like fastest algorithm. But disadvantages are there. if if we allocate the memory, then there can be a remaining unused memory. Okay. And then like our memory is going to be wasted. Okay, for example, if we have allocated lot of processes, and like lot of memory is wasted, then if a process is there and it requires larger memory, so we cannot allocated. So it is a disadvantage of the first fit. Hope so you got it what is first fit. So now let us look next fit. It is similarity, it is similar to first fit. It, like you can say, it is modified version of first fit. So what generally for next fit do, for example, if we allocate one process, then it doesn't searches from the beginning, it searches after when the first like where the first process is kept. It just searches after where the first process is kept. So what is the advantage of that is it requires less searching time. Okay. The next one we have is best fit. So what best fit generally do is it searches for smallest free partition. It searches for smallest free partition in order to allocate the memory to that process. So it searches the whole memory location, and it tries to find a hole that is smallest and it is adequate to keep that process. Okay. So the advantage is it is better than first fit, as it searches for the smallest fit partition available. But we have disadvantage that it have to search the whole memory. So we have to search, so it creates like there's like it is not that much efficient if we just see for the time being. So it is not that much efficient, and it can also create useless holes. And the last one we have is the worst fit. So generally what worst fit is do, it is just a reverse process of best fit. It searches for the largest available memory partition. It searches for the largest free partition available. And what is here, what the advantages we have for that is it reduces the rate of production of smaller gaps. Okay. But at the same time there are certain disadvantages as well. For example, if the one process is there, and like we just allocate the smaller process in that larger one, there can be chances that if a larger process is there, and as we have already used the larger section, so we don't have enough memories partition available to accommodate that larger process which is coming at a later stage of our process. Okay. So hope so you got it to know what is memory partitioning, and like we discussed fixed partitioning and variable partitioning. So thank you for being there, and have a nice day.